Hi everyone, something a bit different again. We have a communications receiver which was manufactured in the 1970s, possibly 1970. I think that was the year it came out. It's a Lafayette. Your name there shows up. Will show up in a minute. Trying to do these things without a dozen different hands, it's not very easy. There we are. It's a Lafayette HA-600. It's fully working. I've got it rigged up to a simple aerial, so it's obviously will only receive very limited things. The other aerial's in the other room. It's a bit difficult to run that through and film at the same time. So anyway, I'll have a quick look at it. I will open it up. We'll have a little look inside. We might make it in two parts. Possibly will, actually, because it's going to be too long otherwise. And as I say, this was made in Japan, 1970s. They were made for either 110 volts or 230 volts, so it can be used here or in America. The bands were, as far as I know, exactly the same. What I've actually done is the cover is on at the moment, but it's not screwed on because we're going to take that off later and have a little look inside. Mind you, there's a lot of air in there, so it's not filled up with loads of components. Anyway, let's have a look at the scale. I'll get down on my knees. Try the old camera out. I'm still getting used to the camera. As you can see, they're the bands. I'll hold it on there so you can see what bands we've got. 10.5, 30 megacycles. It's on the way down. So they're your bands. To select the bands, you've got your band selector there. That's the RF gain. Find it in a minute. There we are. There's the band selector, and they correspond to the bands I just showed. So the one on there, 10.5 to 30 megacycles, is actually right the way around. You would turn that round, and that would change your bands. The bands I've got it set on at the moment is the normal broadcast band. Which is that one there. I won't keep it on too long. I don't want to do any what's it with the thingy. But that's on one of the normal AM band. Anyhow, coming further down, a lot of people will probably know this anyhow, but I thought I'd put it in. You've got what is known as band spread. Now, the idea of band spread is you set your pointer, if you like. We'll take this. There's going to be nothing on there, but on there there's a little A. There's an A there, and that covers that block where it's highlighted from 3.5. That's A. Now what you would do, you'd set that pointer onto A, obviously switch to that band, which is 1.6 to 4.8 megs, and then you would go down to a second set of readings. On there you'll see on the bottom one, A, 80 meter band, and by turning the bottom control, and move along, and that will band spread on that thing. So you've got 3.5, which corresponds to 3.5 there, and you go the other end and you go up to the 4. So where's that? It is between those bands there. So what you're doing, you're enlarging that range into a much wider range, and you can tune more accurately and more with more sensitivity. When we open the back up, I'll show the 2 tuning capacitors which we use and how it's done. Over to this side you've got your S units, and that is the signal strength. If I tune something in on that, for a start I'm on the wrong band. Right, let's try. Right, let me check the aerial. Hold fire for a minute. How's that time, Mark? I've broken up halfway. I'm going to do it in 2 lots. I'm doing 2 lots. Right, sorry about that. The bad interference is due to the fluorescent lighting. You can see what I mean when I alter the band spread. You bring in different stations. Well, hopefully that's the idea. I'm doing the top one again. See, so you get a much wider choice to tune in the station exactly right. And if we look at the S meter at the same time, as we drop out of the station, it goes down, and tune it in, you reach 7, carry on doing it, it'll drop down again. So that is your tuning, your S meter or signal strength on your tuning. Some radios had like a magic eye which did the similar thing, perhaps not as accurate as this one, but it gave you some idea. You've got a logging scale along the middle there, where you set your needle there and you actually do a logging scale to get it even more accurate. The rest of the controls, you have a jack socket there for your earphones, your functions. You've got your function control there, it's worn a bit, but right the way round you've got SSB, and that is sideband. I'll come to that. The next one's your AF gain. It does exactly what it says, the audio frequency gain. Next to that, not quite as far along as that, is your another control, which at the moment it's not doing anything because you're not switched to it. But if I switch now to single sideband, this one will bring in a BFO, which is a beat frequency oscillator, And what it does with upper or lower sidebands, you only you do away with a carrier. The carrier is needed to receive sensible stuff, if you like. So what they have to do is to provide a local oscillator to replace the carrier, and that's done by altering that so the frequency changes depending whether you're on the lower sideband, or that'll be upper sideband where that control is, and that side's the lower sideband. I haven't got a demonstration station, so unfortunately I can't show it more than that. Turn that back. The RF gain is another gain, which is the RF gain, which is the front end. You've got the audio gain. That pot's a little bit dicky, it doesn't always want to work. It needs a little bit of switch cleaner in it. And the final one is the antenna trim, or the aerial trim, and what that does, not on this band obviously, but if you've got some of the other bands, it just trims the aerial, and by that it effectively changes the length of the aerial, which controls the wavelength. It's quite technical, but it effectively alters the length, so you get the correct length for the frequency that you're trying to get. But as I say, this is basically on weak signals. Anyhow, that's covered the front part. What I'm going to do, I'm going to make a second part, which we'll have a look inside and at the terminations at the back. I will quickly add, before we go for the first part, the loudspeaker is not internal, it's an external loudspeaker, and that is connected at the back. Anyhow, that's all for the first part. I will do the second part, so the second part will be coming up very soon. Thanks for watching the first part.